Right. So thank you very much for coming, or choosing to come to this talk. You had so many other interesting topics to choose. Thank you for coming to this talk. This will be about Bloom's taxonomy. I'm Sebastian Lasiewski. I've been teaching since 2002. Right from the beginning, my teaching tended to gravitate towards English in academic contexts. I prepared people for exams, including university entry exams. In 2013, I started to teach on pre-sessional courses. Since 2017, I have been involved in foundation year programs. This is when I began to teach research methods, which is my favorite subject to teach. And I'm doing this until now, as I'm a senior lecturer and academic leader for research at Bloomsbury Institute, London. I'm saying this to add a bit of context to what I'll be talking about today. Also, I've been coming to IATEFL since 2012. Now, Bloom's taxonomy is something that for quite some time I have intuitively felt to be useful for students to be familiar with, but I never had a good way of teaching it. I wanted to show students an example where the same piece of information would illustrate different levels of cognitive engagement. So I came up with a little presentation which I'm going to show you now. So I start by explaining that there are different levels of cognitive processing: knowledge, comprehension, application, analysis, synthesis, and evaluation. Those at the top are called higher order thinking skills. Then I explain what each of those means by referring to this example. So I ask the students, what is it? And some of them would say that it's an equation. Okay, do you know the author of this equation? A few students usually recognize that it's Albert Einstein. The next thing I ask is, would you be able to read this equation out loud? So someone will read E equals mc squared. Okay, so now if I memorize E equals mc squared, and I say to somebody, you know what, E equals mc squared, does it mean that I understand what I'm talking about? And the students, as you now, usually say, no, not quite, not really. So it's a good opportunity to introduce the word parrot used as a verb. If I memorize and repeat E equals mc squared, that's parroting. If I memorize and repeat it without understanding what I'm saying, that's parroting. So I could be parroting E equals mc squared, but that doesn't mean that I understand what I'm talking about. It is possible to memorize information, but not understand it. Understanding is a more complex cognitive process. Now, before I move on, I just wanted to say that I included this little presentation in our foundation year program to explain to students why it's so important to paraphrase and summarize rather than quote passages word for word. It's not so much about similarity reports and plagiarism, it is primarily to demonstrate our understanding. Then I explain the rest of the taxonomy a bit more briefly. So, I wanted to say something else here. So it's about demonstrating our understanding. Now, how do we demonstrate that we understand what we're talking about? One way to demonstrate that I have some understanding of this equation would be by paraphrasing it, right? So if I'm able to say the mass of a body multiplied by the speed of light squared is equal to the kinetic energy of that body. Or, energy and mass are two forms of the same thing. If I was able to spontaneously refer to the different elements within this equation and not just rely on a memorized phrase, that shows some understanding of what I'm talking about. The rest of the Bloom's taxonomy I explain a bit more briefly. So application would be maybe doing some calculations. We know that c is the speed of light, 299,792,458 meters per second. What do I put for m? Can I put my body mass? Maybe 80 kilograms. Okay, and then what do I get? So the speed of light is in meters per second. My body mass would be in kilograms. What about energy? Would it be in joules? So it turns out that I'm not quite able to apply this equation. Analysis is breaking material into its constituent parts and determining how the parts are related to one another and to the overall structure. So I suppose that converting E equals mc squared into this would be evidence of analysis. Synthesizing means combining different information and creating something new that would be more than a sum of its parts. For example, I could combine Einstein's equation with the second law of thermodynamics and perform some more complex calculations. And finally, if I was able to say that when Einstein came up with his equation, he treated the speed of light as a constant, but in light of the most recent research, it turns out that the speed of light is not a constant, and therefore his equation was not complete. I'm making this up now. The speed of light is still constant. But my point is that, no, you believe for a second, yeah. My point is that I would only be able to say something like this after studying this equation thoroughly, reviewing the most recent relevant research, perhaps collecting and analyzing my own data. Only then I would be in a position to evaluate Einstein's work, and that would be the highest level of cognitive engagement. So this is my little presentation. As I said, I used it to explain to students why we need to paraphrase and summarize, and more generally to get them to realize that as they move into higher education, studying will no longer be about memorizing facts and figures, but they will be expected to demonstrate some deeper engagement. This little presentation, of course, is far from perfect, and I will say why. But first, I want to say a few more things about Bloom's taxonomy, which maybe some of you will find surprising. Firstly, this is Mr. Benjamin Bloom, American educational psychologist, who is not one person who came up with the equation. The actual authors of the taxonomy are these 34 educators who took part in a series of conferences between 1949 and 1953. That resulted in the publication of this book in 1956, which I read. Mr. Bloom was the lead editor of the book, but not a single author of the taxonomy. Another thing is that maybe some of you were thinking that you have seen Bloom's taxonomy before, but the skills were different. If that's what came through some people's minds, then yes, you're right. Bloom's taxonomy was revised, and the revised version was published in 2001 in a book edited by Laurin Anderson. If you look carefully, you'll notice that one of the original editors also took part in the revision. So, as a result, there are two versions of Bloom's taxonomy, the original one and the revised one. Yeah. Okay. That's the reaction I was hoping for. So the revised version differs a little bit. Instead of nouns, there are verbs. So knowledge, instead of knowledge, there is remember. Instead of comprehension, there is understand, and apply, analyze. And then a major change higher up. Evaluation is no longer at the top of the list, and instead of synthesis, there is create. The reason why these two swapped places is that at the time when the original taxonomy was proposed, there was not a lot of evidence to prove that evaluation was more complex than synthesizing, whereas the authors of the revised taxonomy looked at some statistical evidence showing that creating is cognitively more complex than evaluating. So firstly, Bloom's taxonomy was not exactly created by Mr. Bloom. Secondly, there are two versions of Bloom's taxonomy. And thirdly, there was never a pyramid. So I read the original 1956 taxonomy and the 2001 revision, and neither of the books presents the taxonomy as a pyramid. It's quite ironic that if you type Bloom's taxonomy in Google, pyramid is the first thing that will come up. The original Bloom's taxonomy was presented as a list of skills with sub-skills and sub-sub-skills. It was quite a long list, by the way. And that was the case for each of them. Each of the 6 skills had sub-skills and sub-sub-skills. The revised taxonomy was presented as a table with the 6 skills in columns, cross-tabulated with different types of knowledge. So factual knowledge is knowledge of specific details. For example, Paris is the capital city of France. Conceptual knowledge is knowledge of concepts and categories. For example, knowing the concept of a capital city. Procedural knowledge is knowledge how to do things, and metacognitive knowledge is knowledge about learning. Yeah, I agree. So the revised taxonomy looks at the knowledge dimension and the cognitive process dimension, and recognizes that different types of knowledge are involved in different cognitive processes. The original rationale for Bloom's taxonomy was to facilitate communication among examiners. So Bloom's taxonomy was created with testing in mind, to be clear what we are testing. What we are testing here. Are we testing memory? Are we testing comprehension? Are we testing something else? The authors of the revised version went a bit further and recognized that once it's clear what we are testing, teachers will have a better idea what they need to teach and learners what they need to learn. I find that Bloom's taxonomy helps to pinpoint what students are getting wrong in their academic work. I'll show you a couple of examples. So this is a paragraph from a student's assignment paper. The text highlighted in purple was picked up by Turnitin as copied. Just in case not everyone is familiar with Turnitin, it's software that detects similarity. Some of this text was marked by the student as a quote, there are quotation marks there, but the rest of the text, which is also highlighted in purple, was also copied. So what this student did was just retrieving information, which could be evidence of learning if it was under exam conditions. That would be evidence of memorizing. But if we're talking about an assignment paper that the student works on in their own time, having access to all available resources, then presenting copied and pasted text is not of great value. We would want to see, at least, that the student understands this information. Understanding is demonstrated through interpreting, exemplifying, classifying, and so on. In this particular case, understanding could be demonstrated through paraphrasing. Okay, I'll show you another piece of work from a student. You can see some people are taking photos. Okay, that's great. Here is another passage from a student's assignment paper. This student collected some data using an online questionnaire and presented the results in a pie chart. Underneath the graph there is text that explains what the graph shows. However, the problem is that the text simply duplicates the information from the graph. 8 people said daily, 20 people said once a week, and so on. So what is lacking here is the skill of summarizing, finding a general theme or being able to identify major points. Are you running away? No, okay. Okay, I'll show you another piece of work from a student. So what we're looking at here is the definition of organizational culture. The student gives us a source and a quote. And then again, this time using the phrase corporate culture, source and quote. And yet again, term, source, quote. So we are presented with 3 quotes, quote after quote after quote. There is an attempt at the topic sentence and the summarizing sentence, but these are quite vague and generic, and they don't really demonstrate understanding. possibly the only thing that shows some engagement, some criticality, is this little phrase in a similar vein, which suggests that there is similarity between the first and second definition, but not really saying where that similarity is. There is no actual comparing. So, as a reader, I don't understand why this person is giving me 3 definitions. They're just throwing it in, make of it what you will. As a matter of fact, there are some more serious problems with this particular piece of writing. When I looked at those quotes more closely, it turned out that none of them is a real quote. Each of them is probably a paraphrase, and especially the first one, I mean, all these sources exist, so especially the first one is a rather clumsy paraphrase. Believes that a group discovered, as it dealt with its problems with external adjusting and internal cohesion, which has worked sufficiently effectively to be regarded valid, along with consequently, to be imparted by prospective participants as a proper way to perceive and express oneself, right? So it's likely to be a result of paraphrasing software, or maybe back and forth translation, or I don't know what. But anyway, my point is that the skills identified in Bloom's taxonomy are useful, are needed by our students. And the framework can provide vocabulary that teachers might use to explain to students what kind of engagement the students are expected to demonstrate. On the other hand, some teachers don't seem to appreciate Bloom's taxonomy. I heard from a few colleagues who are amazingly good teachers that they don't particularly like Bloom's taxonomy. So that prompted me to look at the most recurring criticism of the framework, and I found an online article titled "Here's What's Wrong with Bloom's Taxonomy." The author reports that one problem that people have with the framework is that it seems to present a false vision of learning. Learning doesn't really happen in a linear way, and it's not quite true that the skills can be performed separately. Well, there are some statements in the taxonomy that could be interpreted as a suggestion that learning is a hierarchy. For example, the authors recognize that understand is more cognitively complex than remember, apply is more complex than understand, and so on. Here is another quote that might suggest a hierarchy. To understand procedural knowledge is a prerequisite to being able to apply procedural knowledge. However, to someone who has read, especially the revised taxonomy carefully, it is clear that the authors do not see learning as a linear process. Here the authors say that understanding conceptual knowledge helps one remember factual knowledge. If we understand, we're more likely to remember. Not remembering first and then understanding, but the other way around. Here is another quote. Analyze, evaluate, and create activities increase students' understanding. So, understanding is improved through analysis, kind of going backwards, not remembering first and then analyzing, but the other way around. Even the original 1956 taxonomy recognizes that evaluation can be a prelude to the acquisition of new knowledge, new attempted comprehension or application, or new analysis and synthesis. The authors of the revised taxonomy explicitly say that the categories do not form a hierarchy and that they are allowed to overlap. So this argument that Bloom's taxonomy presents a false vision of learning is a straw person argument. The authors never claimed that the learning is a linear process, or that the skills can be performed independently. When children learn to read and write, it's not quite the case that they first need to remember all the letters or all the phonics, and only then they may be able to understand them, and only once they've learned and they remembered and understood them, they may be able to apply them. That's completely not how it works. We do these things at the same time, or almost at the same time. This is also a weakness of my little presentation with Einstein's equation, but it's hard to find an example that would illustrate performing each Bloom's taxonomy skill and at the same time clearly and neatly show the difference between them. So all this misunderstanding around Bloom's taxonomy prompted me to investigate it a bit further. So I had these conversations with colleagues. I organized a mini focus group. I asked the following questions. So I will answer them myself, and then I will add what I heard from the colleagues. As far as I remember, I first heard about Bloom's taxonomy when I was already working as a teacher, probably back in 2010. I wasn't introduced to Bloom's taxonomy as an undergraduate student or a master's student, but I wish I had, which leads to the next question. I'm inclined to think that it would be useful to familiarize students with Bloom's taxonomy. On the other hand, some teachers say that the framework doesn't need to be taught explicitly, but the particular Bloom's taxonomy skills should be built into teaching and assessment. And this is a fair point. Perhaps students don't necessarily need to know that these skills are called Bloom's taxonomy. What's more important is that they demonstrate the right skills. Still, I'm thinking that a situation where somebody has gone through higher education and never heard the term Bloom's taxonomy doesn't quite feel right. Another point that came up was how Bloom's taxonomy relates to critical thinking, on which there is so much focus nowadays in education. So, critical thinking is usually defined as the ability to analyze and evaluate information that we are presented with, but critical thinking also involves all the other Bloom's taxonomy skills, as the authors of the revised taxonomy pointed out. They concluded that none of the skills could be replaced by critical thinking. So it could be said that critical thinking is more of an umbrella term, whereas Bloom's taxonomy identifies different aspects of cognitive engagement. Yet another point raised in my mini focus group was that while it might be useful to familiarize students with Bloom's taxonomy, it needs to be made clear to the students what kind of engagement they are expected to demonstrate. And expectations will differ depending on the level. When I did my mini presentation, it was to explain to students why we need to paraphrase and summarize, but simply showing Bloom's taxonomy to students without a proper explanation what kind of engagement they are expected to demonstrate could possibly cause more harm than good. For example, it wouldn't be very helpful if students were led to believe that they now need to be creating something original. Which leads to the next question. My impression is that people who talk about Bloom's taxonomy often have a rather vague understanding of the particular skills. And that also includes me. For example, what does create mean? In the revised taxonomy, creating is another word for synthesizing, and it does not necessarily involve originality or uniqueness. To create is to draw upon elements from many sources and put them together into a novel structural pattern relative to one's own prior knowledge. Okay, so here is a little note written by my 5-year-old daughter. She's learning phonics. When I saw this message, I wasn't sure if this is an example of apply or create. And I think it's both. There is applying the phonics that she had learned, but at the time when she wrote this message, she only knew the simplest phonics. So in order to write it, she needed to bring in her other knowledge, do a bit of problem solving, and the result is a novel structure. So I think it fits the definition. Draw upon elements from many sources and put them together into a novel structural pattern relative to one's own prior knowledge. Maybe I'm stretching this definition. Finally, to me, the most important Bloom's taxonomy skill is understanding. And I can refer to what I heard in my mini focus group from a colleague who is an experienced senior lecturer in accounting. So he said that quite early in his education, he was taught how to calculate standard deviation. And he understood what standard deviation was. But it wasn't until he did his PhD research, where he performed some complex statistical calculations, that he understood what standard deviation can actually tell us. So understanding is a continuum, and it gets deeper with application, analysis, and all the other cognitive processes in the taxonomy. To sum up, I feel there is insufficient understanding of the Bloom's taxonomy skills and too much vague assumptions about what each of the skills means. Especially educators should be well informed what each skill involves as they design teaching and assessment. Students might be introduced to Bloom's taxonomy explicitly, and I personally would have liked that as a student, or they might be introduced to particular Bloom's taxonomy skills with a clear explanation what kind of engagement they are expected to demonstrate. Finally, I think Bloom's taxonomy might have a renewed relevance when it comes to presenting evidence of learning. Most of the time, learning is demonstrated in written work. Some of it is under exam conditions, but probably most of the time it's through written assignments. Now, since AI has become available to everyone, written work seems to be less credible as evidence of deeper engagement with the studied material. At the moment, AI is able to fake synthesizing. It's not very good at evaluating. So having an understanding of Bloom's taxonomy skills might help us recognize if a piece of writing is likely to be AI generated. Also, considering how fast technology is developing, we can expect that fairly soon AI will be able to perform more complex cognitive work. I like the analogy to the flying machine, a bit of a cliche. It took around 60 years from the first flight to moon landing, and it seems that technology is developing even faster these days. So perhaps Bloom's taxonomy can help educators design assessments that would be AI-proof. So yes, this is all that I have time for today. I'm recording this talk, and if everything works, this video will soon be available on my website, as well as on my YouTube channel, so don't forget to subscribe. Thank you very much.